If you correctly use these 6 effects, you know how to make your sound better. You have to apply these 6 effects to improve your audio in post-production based on the audio quality and situation. Not all the effects are required, and I will discuss details about this as we go through the process. To apply these effects, I will be using Audacity, the most simple yet powerful audio editor. If you want to use any other audio editor, that's fine. The process of making your voice sound better is pretty much the same across all software. I will use this audio clip to show the demo. Let's hear it first.
I will use this piece of audio to show the demo of how to make your sound better. I am recording in a consistent volume, so less work to do in the post-production.
Okay, we see a couple of issues in this audio. Its volume is lower than standard volume and it has some noise. That noise was visible on the playback meter and can be heard in the headphone with a louder volume. If we see the list of effects, noise reduction is the first effect. How much noise you have to reduce depends on for which purpose you are editing your audio. For example, if you are editing for YouTube, you may get away with some little noise. If you are preparing audio for ACX, you have to take the noise floor below -60 dB. That means no noise can be seen in this playback meter. Though here it looks like a flat line, it can be seen if I adjust the track size. From the menu, go to View, Track Size, Fit to Height. You can also use keyboard shortcut Command Shift F. Now the noise is visible. There is another way to see this timeline which also shows the volume level. If you right-click in this region of -1 to 1, you see 2 options, linear and dB. The default one is linear and switching to decibel shows the volume level of each peak. Instead of looking at the playback meter, you can get the information here. As the linear is the default one and most people are used to seeing that, I am switching back to linear. You can try dB display editing to see if it is more convenient. Let's reduce some noise here. Select a part of the audio with only noise. I have selected from the beginning, but it can be anywhere from the audio as long as that is the noise you want to remove. After selecting the noise, go to Effect, Noise Reduction. Noise reduction is a 2-step process, and the first step is to give Audacity a noise sample or noise profile. When Audacity will find a match between a piece of audio and the noise profile, it will consider that piece as noise and will reduce it. Click on Get Noise Profile. For step 2, select the audio from where you want to remove the noise. Typically we want to remove noise from the whole audio, so I select the whole clip by double-clicking. After selecting, go to Effect, Noise Reduction again. In step 2 you can see 3 sliders. First one is how much noise you want to reduce when noise is found. You can adjust the slider, but keep in mind too much noise reduction degrades the actual audio quality. Next is sensitivity, and it works together with noise reduction. If you set the sensitivity to 24, it will be most aggressive in noise reduction. For noise reduction and sensitivity, use the default 12 and 6. If you have to go higher than that, then you have to think about your recording environment. Noise is something you have to take care of in recording, not in post-production. Also, Audacity noise reduction is only for white noise, so don't expect something magical from noise reduction. After noise reduction, a gap is introduced in the digital data which can cause some harshness. Frequency smoothing bands close that gap. The default value is 3, but I prefer 0. Because with a value other than 0, the voice is a bit changed. If no side effect is introduced after noise reduction, use 0, otherwise start with 1. Keep the Reduce Radio button selected to reduce the noise. The residue will give you the audio that is being removed. Click OK and noise reduction will be applied. You see this line has become flatter as those noise dots are gone, and if I play this, we can see the current noise level in the meter. So it is reduced significantly. Keep in mind, this noise can return back again after applying some other effects like normalization. Because noise is reduced here, not removed completely. The reduced noise can be back again if other effects increase those sounds. We will tackle the issue when we get into it. Let's hear how it sounds after noise reduction and before noise reduction.
I will use this piece of audio to show the demo of how to make your sound better. I am recording in a consistent volume, so less work to do in the post-production. I will use this piece of audio to show the demo of how to make your sound better. I am recording in a consistent volume, so less work to do in the post-production.
It seems the audio quality is not degraded, but the noise has been reduced. Let's apply our next effect, EQ or equalization. You will find the EQ effect through graphic EQ or filter curve EQ. I choose the filter curve as it offers more flexibility. It shows my last applied EQ. Let's flatten it. Basically, EQ is the process of increasing or decreasing volume by frequency. This greenish line, which is currently at 0 dB, decides how much increase or decrease to make. When it is on 0 dB, it changes nothing on those frequencies. If I move this line higher, it will increase or boost all those frequencies under that line. Of course, we are not going to increase all the frequencies at the same level with EQ. Then it would be simply a volume increase, not equalization. To control this line, you can click on 2 points and drag them to adjust. EQ is a quite vast topic itself. To keep this tutorial beginner-friendly, I will only apply the built-in EQ available in Audacity. Go to Manage, Factory Presets, and you will see a list of EQ. If you have watched other YouTube tutorials, you may be advised to use a bass boost. For voiceover, it is a bad idea to apply a bass boost. In bass boost, 9 dB boost is applied to 20 to 100 Hz. The fundamental frequency of male voice starts around 85 Hz and for females around 165 Hz. Whatever sound we listen to, it consists of fundamental frequency and some other frequency added on top of that. That means when listening to a human voice, there is no frequency below 80 Hz. If you boost below 80 Hz, you will be boosting something that is not a voice and probably a noise. You may be wondering, do you have to know all these things to make your sound better? The answer is yes, you can only make your sound better when you understand how audio works and in which situation what kind of setting to apply. Let's get back to EQ. The boost applied here 100 Hz may not be ideal for many voices. It can introduce boominess or muddiness in the voice. Experiment with your voice and see if it actually improves anything. Instead of a bass boost, you should apply a low roll-off for speech. This low roll-off for speech preset cuts below 100 Hz and may help you with reducing low-frequency noises. Let me show you proof of that. This beginning silent part still has some noise. If you want to see the frequency distribution, go to Analyze, Plot Spectrum. You can see the most strong frequencies here are from 50 to 100 Hz. Though -66 dB is very low in volume, still those frequencies are the strongest in this silent part. Let's finally apply the EQ. Select everything and go to Effect, Filter Curve. From Manage, Factory Presets, select Low Roll-Off for speech. It has started rolling off from 100. I prefer rolling off from 80, as people with bassy voices will have something below 100. Drag these dots to make the adjustment, and we are good to go. This EQ is basically a high-pass filter. You are letting everything pass as it is above 80, and slowing rolling off which is behind 80. Click OK to apply this EQ. Though no visible change in the waveform, we can check the silent part. Those are not visible anymore in the playback meter, and let's check the spectrum. You see frequencies around 50 Hz has now very low volume. So this audio clip will pass ACX's noise test, as the noise is below -60 dB now. You can now move on from EQ to another effect in your effect chain, or you can add another EQ. I will go to Effect, Filter Curve again, and add Treble Boost. From Factory Presets, select Treble Boost. You should also play with other EQs here to get an idea of which EQ is affecting which frequencies and how that affects the sound. 9 dB boost is too much, so I will take this to 6 dB. Do not apply more than 6 dB boost or cut in EQ, otherwise it will be a large gap with other frequencies and it will not sound great. Treble boost can introduce or increase sibilance, so be watchful about that. If treble boost introduces too much sibilance, either make a cut from 5K to 9K region, or does not add treble boost at all. The effect that can minimize sibilance is called deesser, and an editor like DaVinci Resolve can help with that. To keep things simple, we will just add treble boost, and then we will be done with EQ. Let's hear how it sounds after adding those two EQs.
I will use this piece of audio to show the demo of how to make your sound better.
It is sounding better than the original audio, but still, some more work to do. If you need to raise the volume level without changing the audio data, you can use this gain slider.
I will use this piece of audio to show the demo.
Please remember to set the gain slider to 0 before exporting, otherwise you will get the wrong volume level in your final audio. We are now entering into the third effect in our effect chain. This effect can make you sound way better if you can apply it correctly. Most beginners fail to utilize this compression effect properly for the lack of proper knowledge. This is my last applied compression setting, and let me take it back to the default state. So these are the default settings you will get when you open compressor effect for the first time. Threshold and ratio are the key settings for compression. In general, compression reduces the gap between the quiet and loud sounds of the audio. In this illustration, you see loud audio and low volume audio. If you can close the gap, then both loud and low audio can be heard clearly. Even when talking, we say some words loudly and some words quietly. Compression can help in those situations. The threshold value decides which audio is going to get compressed. If audio gets above the threshold, it will be compressed, and the compression amount depends on the ratio. When you use the compressor, the audio data is not lost, it's organized in a different way. If you had used clipping, then those data would be gone completely, and you would get a distorted sound. Of course, the compressed sound will be a bit different from the original sound, but we are used to hearing compressed sound from TV, radios, and all those songs. If you change the threshold slider, this line will change. Here you can see this has not increased linearly, so the output is decreasing slowly with input after the threshold volume. Changing of ratio also affects this line. Ratio 2:1 means, after the threshold, a 2 dB increase in the input will result in a 1 dB increase in output. The more the ratio is, the more compression will be done. So how do we find out the proper value of the threshold? Audacity compression is not what it looks like. This compress based on peaks checkbox affects how to use this compressor. Click the help icon and you will be taken to the documentation page of this effect. This is a great place to learn more about Audacity and audio editing. If compress based on peaks is unchecked, which by default, Audacity uses RMS value instead of the peaks. The value you see in the playback meter is the peak value, not RMS. So if you set a threshold value by looking at the peaks in the playback meter, you are entering the wrong values, and maybe no compression will happen. That will be a total waste of this effect. How do you find the RMS value then? You have to use a plugin for that, and you can see that under Analyze menu. For you this measure RMS will not appear, so go to Add Remove Plugins. Scroll down a bit, and you will see the Measure RMS plugin. I already have it enabled, you have to enable it, and then click OK. Let's measure the RMS value of this noise floor. It is around -74. Now let's measure the RMS of some peaks, because you will want to compress these louder sounds to get close to the quieter sounds. Now select More Audio and measure. So we see the lowest RMS we get here is -29, and we got some peaks around -26. As this measurement is in hand, go to Compressor Effect. We can safely set the noise floor to -50 dB as we have no actual audio behind that point. Though the RMS was -74, we should not go too close to that value as some noise can be mistaken as audio. I could have set -60, but -50 is fine as it has a large gap with the actual audio RMS. I am setting the threshold to -30, so anything above -30 will get compressed. You should experiment with several values after you get the RMS measurement to get the best result. I am setting -30 as I have seen the lowest value of the peaks -29, so minus 30 will compress those. I will set the compression ratio as 4:1, which is a pretty standard compression ratio. A higher ratio will result in too much compression, and it depends on the audio if you need that much compression. For standard audio recording, ratio 4:1 works fine. Let's move it a bit left, so we can see how the waveform is changed. I forgot to uncheck the 0 dB makeup gain checkbox. I undo this and go to the compressor again. This checkbox is normalizing the audio after compression, but I will normalize it a bit later with a different value. Let's apply now. So you see how it changed the waveform. See again. Let's hear it.
I will use this piece of audio to show the demo of how to make your sound better. I am recording in a consistent volume, so less work to do in the post-production.
Okay, so what would happen if I compressed with a minus 20 dB threshold? Let's check that quickly. From history, I will undo the compression and go the state after those two EQs. I will keep all other settings unchanged and move the threshold to minus 20. You see, only this tip was a bit compressed, but the overall audio remains the same. Because those audio levels are not crossing the threshold level, hence no actual compression is applied. I hope you now understand why we have to find the proper value for the threshold. Let's get back into with minus 30 dB threshold compression. Our next effect is the limiter, and this effect should be applied in certain cases only. When you have to use a limiter, you should only apply a hard limit. Other options may clip your audio, and which in turn may result in distortion. Before showing in which case you should apply limiter, I will show our next effect, normalization. After normalization, you will better understand when to apply a limiter. To normalize, select the audio and go to Effect, Normalize. Normalize is a volume control, and this value sets the volume of the loudest part of the audio. All other parts of the audio increases in the same amount, as does the loudest part. Here you can set the maximum value of 0, which is also the maximum value in the playback meter. This illustration will make it clear what normalization does. Let's say this is the minus 3 dB level. If you normalize to minus 3 dB, the loudest part will touch minus 3 dB. The volume of all other parts will increase in the same amount, including the noise. So normalization can bring back the noise you reduced earlier. The value of this field depends on case to case. Normally I prefer to use minus 3 dB, as that leaves some headroom. As this audio is quite balanced, I can use minus 5 and still get a good volume level. When I play this, you will see it is reaching a maximum of minus 5 in this playback meter. Let's hear it.
I will use this piece of audio to show the demo of how to make your sound better. I am recording in a consistent volume, so less work to do in the post-production.
That's quite an improvement in the audio quality. As I said earlier, normalization can bring back the noise as it raises everything. We can see some noise is back in the silent part after normalizing. So I can apply noise reduction again with gentler settings. This little amount of noise does not matter for YouTube videos or podcasting. But if you are in a situation where you have to take noise floor beyond minus 60 dB, you can use a noise reduction that will just get rid of the noise. Every time you apply noise reduction, be sure to check audio if it is okay. Let's check.
I will use this piece of audio to show the demo of how to make your sound better. I am recording in a...
There is one more effect you can use in addition to normalization, or instead of normalization. On many platforms, you may have to conform to the LUFS level to submit audio. Loudness normalization helps in those cases. Select the audio and go to Effect, Loudness Normalization. Then select Perceived Loudness in this drop-down and set the LUFS value. Some platform allows minus 14 LUFS maximum. Let's see how that sounds. I have applied loudness normalization after normalizing.
I will use this piece of audio to show the demo of how to make your sound better. I am recording in a
Though when you use loudness normalization, the other normalize is not necessary, though it will do no harm. I am going back to before normalizing and after compression state. I will set the same -14 LUFS as before. Visually it is no different, let's hear it.
I will use this piece of audio to show the demo of how to make your sound better. I am recording in a consistent volume, so less work to do in the post-production.
Practically you do not need to hit -14 LUFS, and should keep some headroom. With -14 LUFS it is touching 0 in the playback meter, so I will use another value like -17 LUFS.
I will use this piece of audio to show the demo of how to make your sound better. I am recording in a consistent volume, so less work to do in the post-production.
This time it is looking okay. With all these effects applied correctly, you can still fall into an issue. In that situation, the limiter can help, and let's see it briefly. To show the use of the limiter effect, I will use a different audio clip. You can see in this clip very large spikes compared to other parts of the audio. It is an extreme example to show the best use of limiters. Normally compression can take care of this type of issue, but for extreme cases, compression may not work that well. If you normalize this audio clip, you will see a strange thing. I will normalize with -1 to maximize the volume level. It seems very little normalization is done here. Because this peak is already at maximum level, so no chance for the loud part to grow. As other parts grow the same amount as the loudest part, nothing got a chance to grow. If I delete those peaks and normalize, then you will see a different result. Now the audio is normalized as we expected. But deleting those peaks cannot be a solution, so go to Effects, then Limiter. You will find a limiter after scrolling a bit as it is not part of the Audacity core plugin. Do not use clips as that distorts the audio. Use Hard Limit, as it works as a de-amplifier, or decreases the volume only of the peaks that are above the limit. Set the limit based on the audio recording. -10 is the lowest you can go, and for this audio I am choosing -9. So anything above -9 will be limited to -9. Now those peaks are at -9 dB and normalization will work as usual. You should use a limiter only when compression is not able to solve the issue and the audio level varies. Sometimes you can fall into this issue, so I have included this effect. Keep in mind, if you need to use a limiter, use it before normalizing. So use these 6 effects to improve your audio. Rather than trying to be too fancy with audio editing, you should seek clarity. At least test in 2 kinds of devices after editing, like a sound box and a headphone. Different devices have different kinds of frequency responses, so what is sounding amazing in your headphone may not be that well on other devices. That's why it is important to test on multiple devices, especially when you are new to audio editing. There are no one ultimate settings for audio improvement. It depends on the audio and takes a bit of practice to figure out which is working best. I hope this tutorial will help you on that journey. Best of luck on your journey to audio editing mastery, and thanks for watching. See you in the next video.